This video will look at multiplying radicals. So again, let's warm up your brain and have you do these three problems here with simplifying radicals, things you've done before. So pause the video and let's see how you do. And here are those final results after you simplify them. Please dig in if you got any wrong. It's really important that you understand these skills.
So I started writing songs, I started writing stories. Something about that glory just always seemed to bore me. Cause only those I really love will ever really know me. Once I was 20 years old.
The underlying principle that's really important to multiply radicals is the distributive property. And so we will review that. So this first two examples asks you to distribute the 3 to the quantity 4x plus 4y. And when we do that, we get 12x plus 12y. Remember, you're just multiplying to each term inside. This one is the FOIL idea, or the double distribution, and that we're going to have to do with radicals as well. So let's remember how to do that. You take your first terms and multiply them. You take your outer terms and multiply those. Your inner terms, and your last terms. And then, if you have like terms, you should combine them. And so this ends up, oops, that was a minus sign. Did you notice that? So 3 minus 8 should be a negative 5x. Oops, I did it again. Minus 12. You get the point. All right, now we're going to do the same thing with radicals. And remember, when you multiply radicals, you can multiply the numbers underneath them. So to begin, I have the square root of 3 times 4 times the square root of 2. So my square root of 3 and square root of 2 can be multiplied to get the square root of 6 under that radical. And then the 4 will just be multiplied to the 1 that is understood to be outside there. So you get 4 times the square root of 15 when you multiply your 5 and your 3 together. You should always make sure that you have no perfect square factors underneath your radical after you do that, and we don't, so we are good to move on. There's nothing else we can do there. The second one will require us to double distribute, or FOIL, however you want to think of it. So the square root of 2 times 3 times the square root of 2, these would get multiplied together, and that would be the square root of 4, and we'll take care of that simplification in the next line. My outer terms, 3 times the square root of 2 is just 3 times the square root of 2. My inner terms, a negative 4 times 3 is a negative 12 with the square root of 2 hanging along. And then you have a negative 4 times a negative 3, which is a negative 12. And now clean it up, combine like terms. If you have any perfect squares, you square root them. So the square root of 4 is 2, and 3 times 2 is 6. Here I'm going to combine these. 3 minus 12 is a negative 9, and square root of 2, and I'll make that look better in a second. And then your minus 12 hanging off. So now these need to be combined. 6 minus 12 is a negative 6, and I'm going to put my radical out front. Negative 9 square root of 2. So this is your final answer for that product of two radical expressions. Two more examples. I will do the first one, and then I'm going to set you off to do the second one by yourself. So I need to distribute here, and I have the square root of 6 times 4 times the square root of 3. So again, we can combine the 6 times 3 to get an 18 under our radical. And then I go over and multiply those two terms, and I get 7 times the square root of 12. And you are considered to not be done right now because I have a 9 in there and I have a 4 in there as factors. And so we're going to need to simplify this. And I'll write it out in super detail. The square root of 9 is a 3, leaving the square root of 2 trapped inside. And the square root of 4 is 2, leaving the 3 trapped inside. And then the final cleanup job leaves us with this expression, and I cannot combine those because they are not like radical parts, and so I am done. Alright, I'm going to have you do the second one, so pause the video and come back when you're done. Okay, maybe that one was too easy, as long as your eyes could keep straight what was being square rooted and not. And this was your final expression. There's no perfect square factor in there. We can combine these, and so we are done. And now we get to products of radical expressions that require us to distribute. So I will do the first one with you, and the second one you will do on your own. So the first one, I'm going to take 2 times 7, which are my first terms, and get 14. My outer terms give me a 6 times the square root of 11. My inner terms, there's nothing really you can do except multiply them in that fashion. And the last terms, I'm going to get a negative 3, watch out for that negative sign, and a 66 under the radical. Now you should check to see if you can combine any like terms. And I really can't, so I am stuck with that answer. 66 does not have any perfect squares in it. It would be a 3 and 11, and that can't be reduced. So we are done with that problem. All right, you're going to move on to the second one, and you need to remember what that 2 is doing to that expression. Do not think you can distribute it. You cannot. That is an addition sign, not a multiplication sign. So that problem is really that binomial times itself. And when that happens, there are the shortcuts you have maybe learned in other videos, but maybe not. So you just go ahead and FOIL this and come up with a final result. So pause the video now, and let's see what you do. You may have the question, does it matter which term you put first? It really doesn't, so you could have reversed these, that's fine. I think it's better when you're starting out with these things just to multiply the parts under the radical before you jump to actually square rooting it, maybe to avoid any mistakes unless you're super good at this. 3 more final examples. Again, if you think you've got this, you can just fast forward to the end to see all the answers. Otherwise, walk through it with me and see how you do. So again, this is a distribution problem. And 5 times 6 is 30. The square root of 7 just stays. 6 times a negative 2 is a negative 12. And then I have a 28 times 7, which is 784. 784, believe it or not, is a perfect square. And it turns out to be a 28. I don't know where I came up with that. Probably this 12. So it's 12 times 28. Is that result, and then that number would be 336. So our final result here is 30 times the square root of 7 minus 336, and there's nothing more to do with that. Next example is a FOIL problem. So I will end up with 8 square root of 7, negative 12 square root of 14, negative 12 square root of 3, and a positive 18 square root of 6. Remember, you can always pause if you feel like this is going too fast. Alright, I am looking at these, trying to find any perfect squares under radicals, and none of these have those. And there are no like terms to combine, no like radical parts, so you're done with this one. That's not so bad. And then one last final one, which is back to distribution. So I get this negative square root of 14. So I'm going to take 14 times 5 and get 70 under my radical. This is a negative 3 because of this negative sign. 70 under my radical. And then 2 negatives here make a positive 2 when I multiply those parts. And then when you take 14 times 12, you get 168. So I'm sure I can reduce these two. So we want to find if 70 has a large perfect square in it, and I know I could do 7 times 10, and 10 is 2 times 5, so I'm done with the 70. There is no perfect square factor in there, and that makes things easy. Now how about 168? It doesn't divide by 16 or 9, and I'm just trying it on my calculator. I can see it divides by 4, so I'll just use that fact for now. Oops. And so I am currently at this stage. 4 times 42. The 42 can be divided by 2, but that leaves me a 21, and so that's only a 7 and a 3. So what I'm doing when I'm talking out loud is looking for 2 of any of the same factor, because that would mean I have a perfect square. And I don't. So the square root of 4 here becomes a 2, and 2 times this 2 is a 4, and square root of 42 is my final answer.